Now we're going to talk about acid-base balance, and I'm not going to go into a great deal of depth about this. I'm going to tell you what a buffer system is, but I'm not going to go into any great depth about the mechanics of how they work. First thing you should know is that our body pH is supposed to be between 7.35 and 7.45. So we are slightly alkalotic, not very much, but our blood is slightly alkaline. We would call it alkalotic for relative to our bloodstream if we had a pH above a 7.45. Then we're getting into a range where the body doesn't work quite right. Same thing, if we had a pH below 7.35, we would be in acidosis, and again, the body wouldn't work quite right as a result of that. So physiologically, acidosis is a pH between 7.35 and 7.0, although if we're talking about just pure pH level, that is still alkalotic. But anything above a 7.0 would be considered alkaline, but below 7.35 is acidotic relative to what our body should be. Hope that makes sense. Most ions originate, most things that cause our body to be acidotic or alkalotic originate from cellular metabolism. Now, the acids produced by the body, there's a whole lot of them. There's phosphoric acid, lactic acid, fatty acids, and carbon dioxide in our bloodstream forms carbonic acid, which also makes our bloodstream, adds to the acidity of our bloodstream. That is why when you get a little acidotic, you will actually start breathing a little bit heavier so that you will blow off excess carbon dioxide. We also have ammonia in our bloodstreams. Now, most acid-base balance is maintained by the kidneys. So we pump hydrogen ions, which are the things that make the bloodstream acid. We pump that into urine, for instance. Other control mechanisms that we do have are blood buffers and the respiratory system. Now, I've already mentioned that the respiratory system can compensate by having us blow off excess acid by carbon dioxide. Now, here we go. Acids are proton donors, and you don't really need to know that they're proton donors, but you should know that an excess of hydrogen is an acid. Strong acids will dissociate completely and liberate all of their hydrogen into water. Weak acids, like carbonic acid, dissociate only partly. Bases are proton donors, that is, they will accept hydrogen ions, and strong bases dissociate easily in water, and they will tie up the hydrogen. Weak bases, such as bicarbonate ion and ammonia, are slower to accept the hydrogen ion. So, dissociation of strong acids and weak acids. Well, a strong acid, you're going to end up with lots of hydrogen ions in the fluid. With weak acids, you will get some hydrogen ions, so you'll end up with a weaker compound. Now, blood buffers function to take care of big swings that might occur in the pH of your blood. Basically, a buffer will bind to excess hydrogen in the bloodstream when the pH drops. It will also release excess hydrogen when the pH rises. So these are substances that will react to the presence of an acid or a base in the bloodstream by releasing or absorbing a substance that it needs to. So there are three major chemical buffer systems. There's the bicarbonate buffer system, there's the phosphate buffer system, and a protein buffer system. And these three will help us maintain a balance if we have large rapid changes in blood pH. One of the biggest ones of those that can occur when you drink a cola. And these buffer systems will absorb the acid that is introduced into your system by the cola in a manner that will keep your blood pH within its required range. Now, the bicarbonate buffer system is a mixture of carbonic acid and sodium bicarb. You've probably heard of sodium bicarbonate as something you take when you have heartburn. Well, carbonic acid is a weak acid that does not dissociate much in neutral or acidic solutions, but it will react when there is a strong acid to change them to a weak acid. Whenever you mix an acid with a base, what you end up with is a weak acid and a salt. A strong acid, such as hydrochloric acid, will mix with a weak base like sodium hydrochloride to give you a weak acid like sodium bicarbonate or carbonic acid, and a salt like sodium chloride. Now, respiratory system control of acid-base balance. We've got carbon dioxide in the bloodstream, which is converted to bicarbonate ion and transported in the plasma. Now, increases in hydrogen ion concentrate produce more carbonic acid. Excess hydrogen ion can be blown off with the release of carbon dioxide in the lungs. So your respiratory rate will rise and fall depending on changes in pH. When you start exercising, you actually generate more acids in the bloodstream, which in part helps regulate the respiratory rate. The existence of carbon dioxide in the bloodstream increases the respiratory rate. We blow off the carbon dioxide, and that keeps our blood pH in the appropriate range. Renal mechanisms of acid-base balance. We will pee out or excrete bicarbonate ions if needed, and we will conserve or regenerate new bicarbonate ions also if needed. Just depends on the acid-base balance. When blood pH rises, gets more basic, bicarbonate ions are excreted, and hydrogen ions are retained by the kidney tubules. This would lead to a more basic urine. Most people have an acidic urine, but people who live on primarily a vegetarian or vegan diet may have a basic urine. When blood pH falls, gets more acidic, bicarbonate ions are reabsorbed, hydrogen ions are secreted. So, urine pH usually runs somewhere between 4.5 and 8.0. Again, mostly it's going to be in that lower range, the 4.5 to 7.0 range. You rarely see a basic urine. Some developmental aspects of the urinary system, just a few things to be aware of. Particularly, you may already be aware of this if you have kids, but control of the voluntary urethral sphincter doesn't start until about the age of 18 months, and complete nighttime control may not occur until the child is 4, 5, sometimes even older than that. Urinary tract infections are the only common problems before old age, and those tend to be caused by E. coli. As we age, there is a progressive decline in urinary function. The bladder shrinks. We lose bladder tone with aging, so urination becomes maybe more frequent and with less control. Other associated problems with aging in the urinary system is a sense of urgency that you just suddenly feel you have to pee. Frequency. You have to go to the bathroom often, but there are only small amounts of urine that you produce. Nocturia, you need to get up during the night to go to the bathroom. Incontinence, where you lose control of urination. And urinary retention, which is most common in males as a result of problems with the prostate gland. So that completes everything associated with acid-base balance. Again, I did not cover that in any depth at all. Just understand that we have buffers, which are weak acids, which allow us to either absorb or release hydrogen ions as needed to maintain the pH in our bloodstream.